So we should have lots of time to work. So we're covering 3 of the 4 topics today. So we are here on chapter 10. The lab is due today because AJ has to do the lab tomorrow, so that's why it's due. It's still going to be due tonight. So make sure you do the lab. We should have some time at the end of class today. We should have lots of time to do that. So make sure you do lab 12. We are going to take 2 days on chapter 10, and then when you guys come back next Thursday, because we have the ACC on Tuesday, you're going to do lab 13, and then we're going to stack the review on top of the test. So there are 4 topics. 1 is repeated twice. There's 5 questions on the test. So you should be fine if we'll do our review day, and then we'll take the test on the same day. And then we'll be caught up because we have the early out snow day. Okay.
The early out what?
Or not early out, or late start snow day.
Oh.
That's why we have to rearrange our schedule a little bit. And then we'll be back on schedule. Okay, questions about this kind of a little bit mixed up schedule, we're okay? Okay. All right, let me go over our slides. So again, make sure you do the lab. Lab 12 is due tonight. If you should have been by this afternoon, I will grade it and you can read. So lab 13 is on the I also okay, so the 9th. Yep, you're gonna do lab 13 on the 9th. Okay, so this is kind of a review, this first part. So we have nucleides, and we have some kind of isotope. So what were these labels? Do you remember what these labels were? So this is from like chapter 2. Do you remember back to what is this is like our atomic symbol, and then what do these represent, these numbers? Good, one of them is the atomic number. Do you remember which one? Is it the top number or the bottom number? Good, bottom number is the atomic number. And what does that tell us? It doesn't tell us the mass. Good, this is number of protons. And this is also the identity of the atom. Oops. You're looking ahead? Okay. My pen tool is really giving me problems. Let me try to write on this. This is the identity. Okay, and then you said this one's the mass number. That's true. And what does the mass number tell us?
How many? Where's the? Is it the weight? No.
Tells us the mass number. So what in the nucleus? What has mass in the nucleus? What's in the nucleus? Neutrons. Protons also live there. So our neutrons. This is number of neutrons. Okay, this is very annoying. Number of neutrons plus number of protons. Let's try this. Okay, and then this is our atomic symbol. Okay. So if if we can figure out the number of protons, we can look at our periodic table. That's the atomic number listed on our periodic table, and then we can go and find the atomic symbol. Okay. All right, so if you have this atomic symbol, how many protons, how many neutrons? 92 what? Okay, good. This one is our protons. The bottom one is always protons. So this is not very hard, but you need to not mix it up on the test. So if it's going to help you to have an example on your note card, that might be helpful. Okay, and then what is this again? Whoa. This is protons plus neutrons. Oh, you figured it out? Tell us again. How many neutrons? 146?
I'm gonna get that in my head. That's what I want to say.
So this is protons
Oh my god.
plus neutrons.
I think these next 2 weeks will be over to get my
Okay, and which one was A?
I'm gonna give it 2 overall.
The atomic mass. So this one's A. This one is C. Okay,
Good.
so that's going to be one of the questions on the test, or on the homework and the test. You have to identify how many protons, how many neutrons, what's the atomic symbol, which one is A and which one's Z. Okay, the next thing we're going to talk about is radioactive isotopes. So a radioactive isotope is just something that is unstable, an isotope that spontaneously decays. And this is just a fun fact. Of the known isotopes of all elements, 264 are stable, 300 are naturally occurring but unstable. So that's kind of interesting. Let me show you. This is, if we go to,
So that's not need to know. It's just something.
no, that's just fun to know. Yeah, you don't need to know that. Let's go to, have you talked about ptable? ptable.com in here? Okay. So it comes up with properties, but if you click along the top, there's isotopes.
Yeah.
And you can see all of these different isotopes that are found in the world. So if we click on like titanium and we click and drag, we can see the isotopes that are stable, and then we can also see which ones so these ones undergo positron emission. So there's all sorts. This one, let's see what's blue. Blue is beta decay, and we'll talk about what that is. But you can look and see all these different types of isotopes. So that's kind of interesting. Okay, so we'll go back here. Back to our notes.
Module knowledge check.
All right, I'm going to hand you this paper so you don't have to write it down. These are all of the particles that might show up on your homework or the test. So these you're either going to have to memorize or put on your note card.
Oh, wow, the hell.
So it has a description.
I should have, like, actually.
And it has a symbol, it has the mass and the charge. So on the Alex topic, you're going to need to know the charge and the mass and the symbol. We're going to watch this video.
I played so bad.
Yeah, maybe.
You do it.
Okay, you also need to know some of the properties. So this person is going to tell you which types of radiation will go through different things, and you will need to know that for the topics. I like that video. And that's what you need to know for the ALEKS topics. So it's gonna ask you what can block an alpha particle. So like a piece of paper can block an alpha particle. What can block a beta particle? I think their option is a wall. You could block a beta particle with a wall. A gamma ray is not gonna get blocked with a wall. You have to use concrete or like lead to block gamma rays. So I think that video, and that's linked in the slides also, if you want to go back and watch that again. So I think that does a great job of explaining that. Okay, so we're just gonna run through a few of these, but these are all on your paper, so you have them, but we'll just go through a few of them. So an alpha particle, it has mass, that's why the paper can stop it. The less mass it has, the harder it is to stop. So this has a charge of +2, and it has a mass number of 4. So we use this symbol, alpha, or because it has 2 protons, that means it's a helium nucleus. So we can also use He, 2 at the bottom, 4 on the top. So either of those, ALEKS will recognize if you need to type that in. The next one is a beta particle. So that is just a high energy electron that comes out of a decaying nucleus. It has a -1 charge because it's an electron, and it has negligible mass. So it has mass, but it doesn't have mass because it's an electron. Compared to a proton, it has like really tiny amount of mass, but it does have mass. So that's why it's a little bit easier to stop because it has a little bit of mass, but it's kind of hard to stop because it's so small. The mass is so small. And then I don't think you need to know this, but this is kind of interesting. In a nuclear decay process, if I have a neutron, it can decay into a proton and an electron. The electron comes out of the nucleus, and the proton stays in the nucleus. And so that's what causes this beta particle to come out. The next one is also on your list is a positron. This is just like an electron that has a negative or a positive charge. So it's the same size. It also has mass, but it's really a small mass. And it has a positive charge instead of a negative charge. So I like to think of it as a positive electron. And so this is like the opposite. A proton in the nucleus decays into a neutron and a positron. And we'll talk about this, but what's happening over here is that the mass number on the top, and the atomic number at the bottom have to add up to the left side has to add up to the right side. So this side has a mass of 1, this side must also have to have a mass of 1 on the bottom. The top has a mass of 1 on the left, so the top must also have a mass of 1 on the right. Okay. The next one, I think this is also we're going to talk about, is a gamma. Oh, we're going to also talk about neutron. A gamma ray, it doesn't have any mass. This is just a high energy wave. So it's like in the electromagnetic spectrum. So we have our UV, we have our microwave, we have our visible light, and on that spectrum is also gamma radiation. So it's just a energy wave. So it has no mass and no charge. If you look at the symbol, so we have this gamma symbol, but usually we put zeros on it. So I'm going to draw those. So usually we have as a 0 here and a 0 here. So 2 zeros. Okay. All right, and the next one is a neutron. A neutron can also be emitted from the nucleus. This is the symbol for a neutron. So we have 0, so 0 on the bottom because it has 0 protons, but 1 on the top because the top is neutrons plus protons. So that's another one that can show up in the ALEKS topics. Proton. Proton can also show up. This is the same as, what would this be the same as? What's our atomic symbol? What could we represent this as? H. Good. So this could be, and that's on your paper too. So a proton has what charge? Yep, so we could put a plus on it. Oh, I was going to say, this. We can see this as hydrogen. Let's just write it again. This could be the same as hydrogen. We have 1 proton, 0 neutrons with a positive charge. So that's the same thing. Okay, so like I was saying, we have our original nucleus. This splits into a new nucleus and then some kind of radiation that's emitted. So it could be a particle, it could be a gamma ray. The mass of the sum of the mass numbers on the left has to equal that on the right. The sum of the atomic numbers on the left has to equal the sum of the atomic numbers on the right. So this is like 6th grade algebra. It's not too tricky. We just have to make sure we know what we're doing. Okay, so here we have uranium-238. It is a radioactive isotope, and this is one of the pathways that it can decompose or be radioactive. So this splits into a helium nucleus and a thorium nucleus. So if we look at the mass numbers, the top number is 238. So if I start with a mass of 238, I better end up with 238 on this side. So here I have 4 plus 238, or 234, that gives us 238. So the top numbers have to add up. 4 plus 234 is 238. And then the bottom number tells me I have 92 protons. So I better end up with somehow 92 protons on the right side. So here I have 2 from the helium nucleus, 90 from the thorium, nucleus. So together we have 92 protons on the right, 92 protons on the left. So this is a balanced nuclear reaction. Okay, questions on this? Okay. All right, go ahead and try this one. We have americium-241, and it's going to decay to form an alpha particle and something else. So you should figure out, so write this out and figure out what also comes out of this nucleus if we get an alpha particle. And you should have the list of particles if you need that.
It's 2 protons and 2 neutrons. No, you can just take out 2 protons and 2 neutrons. So 4, yeah.
Okay, are you ready to talk about it? Do you need a minute? Should we talk about it? Okay, so let's start right on this board. So what's the symbol for americium? AM. Okay, and what number should go on the left of the symbol? What should go on the top? Up here. Yeah, 241. This is the mass number. 241 should go at the top. And then what should go down here?
95.
And how do you know that? Okay, you're looking at the periodic table. That's our atomic number. Good. Okay, so this decays. So sometimes we could have something adding together. This one's just decaying to form an alpha particle. So what symbol did you use? Did you use alpha or helium? Helium, okay. Yeah, either of those will work. So helium, and then what goes on our helium? What's the top number?
4.
Good. And what's the bottom number? Good. Okay, and then we're going to add what do we end up with also? What's over here? Yeah. Neptunium, okay. And what numbers go on Neptunium, Corbin?
2, 3, 7, 93,
And 93. Okay, good. So this is the Alex topic. Alex is a little bit different, but this is the Alex topic that comes up twice on the test. So make sure, I mean, it seems pretty straightforward, but maybe put an example on your note card. Make sure you know all the particles that could show up on the, because sometimes it asks you to fill in a particle instead of filling in the nucleus, the new nucleus.
Yeah, you were right.
Okay, so like this one, what would be in this box?
Hydrogen. No.
Maybe hydrogen? So maybe let's figure out the numbers first. What should the number be on the top? 0 should go on the top. Good, because there's 11 over here. There's an 11 over here, so we need 0. And then what should go on the bottom? A 1. Okay, and then what symbol does that match? Okay, and so we could either use a beta symbol or we can just put an electron. It's a positive electron. Okay, very good. That was it for today. So the rest of the time you should either work on your lab, or your pre-lab for lab 13 or your Alex chapter 10.
Are we doing the lab on Thursday?
Next Thursday, yeah. Okay. And then we have one more Alex topic to cover next time. If you want to do it by yourself, that's totally fine. But we will talk